Hello viewers and welcome to a new STM32 World Tutorial video. In this video we are going to continue talking about a topic I made the first video last week, understanding custom USB HID. HID, human interface device. I'll probably mix around in this video, sometimes call it HID, sometimes call it HID. But it's the same thing. It's USB device type, and I covered that to some extent in STM32 short number 9. I don't know, honestly, why I posted that as a short. It should have been a tutorial video. I am going to post this as a tutorial video because that's what it really is. But the last one, I guess, was more of an introduction. As usual, I don't script these videos, so there might be things that I forget at some point and then introduce later. So I strongly suggest you watch this video to the end. Now, if you get incredibly bored about a section in the video, down below I am very careful about putting in proper chapters in these videos, so you can just jump to the next chapter and you shouldn't miss anything you are interested in. Also, I have been educated multiple times that I should always ask people to like and subscribe, otherwise they don't. It is important for a channel like this that people actually do like and subscribe to the video, otherwise it won't grow. So please like and subscribe. And I love getting comments. If there's anything I'm unclear about or that you want to know more about, please do ask me in a comment, and I always reply to those comments. So that's about it. Now, back to the previous video. In the previous video, the one shown here, I got to a point where I could send data from the host to the device. Now that is a little confusing for many, including myself. The direction of USB is always from the point of view of the host. So that is called an out event. The host sent data and that is received in the device, but it's an out event. Now, what we didn't do last time is the other way around, a way to send data from the device to the host. And that is what we're going to finish today, so we can have bi-directional communication between the host and the device. I'm not going to create a new project today. I'm merely going to continue the one we did the last time. And the last time we implemented a callback that dealt with every time it received data. We also, I think we used a buffer of 8 byte only. Today we are going to expand that buffer to the full 64 byte, which is possible in USB, and we are going to make the bi-directional communication work. Now, the key reason I figured out why it didn't work, I had tried this before and I intended it to be part of the original video, but I didn't fully understand and still don't fully understand the device descriptors. If we look at the code, the source we changed the last time, we actually only made one change here, and that was basically we created that out event callback, and that's what we did the last time. But in this file we also had a device descriptor, and originally it was just, I think, A101 and 0C. Now that is actually doesn't define bi-directional channels, but it did work probably because the driver by default is able to send data out on this. Anyway, I have looked at this a bit more and found out that this is the correct minimum USB HID descriptor. It will create the two report, an in channel and an out channel. So basically we'll have the input report, which is device to host. This is the one we are going to use today. And we have the other one, the output report, which is host to device. We are going to have two. Now, this time I'm also setting a size, and this was a little confusing, report size of 8 and a report count of 64, but it's actually in bits. So report size means that we are using byte values, and we will have 64 of those. That is the maximum size we can use. So I have simply added these two channels to the HID descriptor. HID descriptor, yes. So the next step is you need to configure the USB port to actually use this one. And in order to do that, we need to count the bytes in this. It's just an array. It's an array of this one. So this needs to match. So 1, 2, 3, 4, 5, 6, 7. 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. So in the CubeMX, you have that value down here, the HID report descriptor size, and we set that to 24. I have also increased the out report, that's the number of bytes you expect to receive, to 64. So that is pretty much all there is to it. So that is all. Now let's look at the main. Remember last time we implemented this HID out event handler out from the host to the device, which basically use the first byte as a switch statement and then do different things with that. So before doing anything else, let's see if this works. So let's try to run this and see what we have. Down here we have our serial console there, starting the HID test, and then it loops around. And down here we have our let me reset that again. There we go. So this is my kernel messages, and you can see the custom HID, and it comes up as a raw HID device, which is exactly what we want. Now let's try to see if we can actually send data to this device. Now I want to show you one more thing. Over here you can see the LS USB. You can see my custom HID device show up here, and you can see that there is these two endpoints, right? There's an in endpoint, so that is from the device to the host, and there is an out endpoint from the host to the device. Last time with the old one, we didn't have these two endpoints. I think it was defaulting to an out one, but it wasn't there last time. So that is the main change. So let's look at the this one. This was the one we used the last time. So we open and we set the length to 64, and we want to send output, and we want to send 1, 0, 10, 0, 10. Let's try. So we're sending 5 byte only, the rest it'll be 0 padded, the whole thing. And we can see over here we receive 1, 0, 10, 0, 10, exactly as we expected, and that is it. It sends the entire 64 bytes. It has to, because look, now that you set the out report buffer size to 64, it expects to get 64 bytes. If I only sent, I noticed this just before I started making this video. If we only sent 32 bytes, it doesn't receive. You can see this over here. But if we do it right, now it's still waiting for 32 bytes. If I do it one more time, I get the data. So you have to send 64 byte when that out buffer size in here, out report buffer size is set to 64. You have to send 64 from the host to the device, to the gadget. So that is about all there is to it. Now, since we now have the in report defined as well, it becomes almost trivial to send data. All we need to do is to call USB-D custom hit send report. That is all there is to it. So I have made a couple of changes in the source just to illustrate more what is going to happen here. First of all, I have made a global variable up here, which is my in report, and that is 64 bytes long, and everything is set to 0. Then I'm doing a couple of pointer variables, that 32-bit pointers that point into that array I did, so I don't have to copy data around. I just update these values directly. So the now variable, which I use in my main loop, is now a pointer into the first 4 bytes of this array, and the loop variable, the loop counter, is the next 4 byte, and then I have that v variable, which is so 12 bytes in all. Is used of this 64-byte array. Now, when you receive data on the device, remember last time, all that happened was I set that variable v. So the only difference is this time I'll set v asterisk v. So the value of the pointer becomes that. So that was the last 4 byte. Of those 12 bytes. So that is the only change up here. And then down here, I have removed the now, I have removed the loop definitions in this, and I just update that loop directly in that array. And then every second, as usual, my next tick, I will send that report with the entire 64 byte of that in report. And I'll send that out, and that is all. So I'm just sending this every second. I'll send those 64 bytes back to the host. So let's change the HID API tester command line a little bit here. I'm still sending that output because, and then I add here, say I could receive 64 byte. But I'm not interested, so I set length to 12. The device will send it all. It will send the 64 byte, but I'm only looking with the HID API adapter test API tester. I'm only looking at the first 12 byte. That just makes the output. I'm setting a timeout of 2 seconds, 2000 milliseconds. Remember, in the code, it is actually sending every second, so it should. The timeout is longer than that, and then I just read input forever. Let's change this one and say, okay, we say 20, 20, 20 instead, and then try to run that. First of all, you will see that the V is set. I received the buffer, and then you can see I'm receiving data. So let's see what we are receiving here from the client. You can see I'm looking at the 12 byte. The last 4 bytes is those variables that I set up here. The V variable is there. So, we can illustrate that by going back and setting this to 10, 10, 10, 10, 10, 0, 10, 0, 10. And now you can see that the output is 10, 10. It's 0, 10. Remember, it's little endian, so it's the other way around. The first 4 byte, if we look at the code, the first 4 byte, it was up here in the variable here. The first 4 byte is a now, so that will keep increasing. It's simply the UV. Where are we? UV tick, UW tick is the now variable, so that should keep increasing. And the next 4 byte was the loop counter down here. So if we look at here and here, you see the loop counter is fairly constant, but it occasionally switches between 2 and 3. And this should have showed up over here in 1, 2, 3, 4. It's these 4 bytes, right? So you can see the first 4 bytes is the now variable that keeps counting up. It's a 32-bit counter. In milliseconds, it's how many milliseconds. And then the next is this loop counter. And the last 4 is that V variable. So here we go. We have two-way communication going. Notice that it is these reports will always be 0-padded. So it is not a problem if I want to read 64 byte from this. It will happily do so, but the remaining bytes will just be 0. So the device will actually send the 64 byte. We have that here. So it will send all 64 byte, but we can just, it's a feature of the HID API tester that it can just say, I'm only interested in the first 12 byte of this. And it merely makes it look a little bit better. Notice I'm still sending 64 byte because I have to send the full 64 byte. The HID API tester can send less, but the device expects to receive 64 byte every time. So there you go. We now have two-way communication between a host and a device, and it works flawlessly, and it is of course much quicker than using a serial port or I2C or whatever else you could imagine using for this kind of communication. So this is by far the fastest you can do. I think it runs 12 megabit, right, or something like that. So it is. It takes no time to send those 64 bytes and receive those 64 byte back. And this HID protocol, you can just invent your own. You can say, okay, these bytes means this and these bytes means that. So you can build your own protocol and your own device to do whatever you could possibly imagine. A crypto key or a device, an authentication device, or whatever you feel like. You can pretty much do it all. As long as you limit these packages to a maximum length of 64 byte. It cannot be bigger than 64 byte. It's just a limitation in USB. So, but if you look at the protocol we sort of invented in the last one, you see we use the first byte a bit like you would do in a SPI or I2C device as a register point. Is not there. Is here. Right, so we can have the first byte, or it could be the first 2 byte, is sort of a command code. What does the rest of this means? And then you can just have, I mean, I imagine actually I did a LED driver board that can drive WS2812, and it would be an obvious choice to make a HID protocol for that. So you can control LEDs with this over um, over HID. That would be a cool. I'm probably going to make a video about that later. Not next. I got other things to do. But that is about. I'm not sure I can think of much more to talk about. Look at the code. The code will be linked below. What will also be linked below is our the app code repository. Is a link to GitHub, but also a link to the STM32 World Wiki, and I'll do a link on to our Discord server where there is some discussion, and it's probably, if you have any sort of detailed question, it's probably better to put it on Discord than it is to put it in the comments below. It can be a little bit confusing. Yeah, that is about it. I think I covered everything. Now, I should probably understand this HID descriptor better than I do, but I'll have to read more documentation to fully understand this. But this is the minimum descriptor that makes sense where you have a channel. I mean, you could imagine one where you only have a device to host, and we are not interested in the other one, or the other way around for that matter. You could imagine one that only have one channel. It is also possible down here to add more reports. I'll probably maybe do that in a later video, but I think it'll be too long if I do it in this video. So let's stick with what I got now, and that's about it. Please like and subscribe, and as usual, have a wonderful rest of the day.